Hello again. So we've learned how to measure angles on the coordinate plane, and that is to go counterclockwise from the positive x-axis. And we have learned what a radian is, and we've also learned there are 2 pi radians in a circle. So what we're going to do now is we're going to mark the angle measurements in our circle that we did in a couple of videos ago with degrees, but now we're going to mark them in radians instead. It's a very, very important discussion to have when we start to talk about the unit circle, which will be coming up real soon. Okay, so the first thing we're going to do is we're going to mark our 0 radians. We always measure with respect to the positive x-axis. Okay? We go all the way around the circle counterclockwise. And where do we end up? We end up at 2 pi. 2 pi is the full circle, is one complete revolution of the circle. So now we need to start breaking up that 2 pi into pieces based on what we did earlier with this circle. Remember that on this circle, we said that each one of these pieces here represents 30 degrees, or a third of that right angle, and each one of these pieces to the center line here represents 45-degree angles, or 1/2 of the quadrant. So let's talk about what we have then. Alright, so if we start at 0 and we go counterclockwise around the circle, 1/2 of a rotation. So I'm going from here to here. I hope you can see that if the full revolution is 2 pi, then half the revolution is simply pi. Okay? There's simply pi. I'm going to erase this 2 pi just so it doesn't confuse us here. But we're going counterclockwise. We'll put it back in just a minute. Okay? So, halfway from 0 to pi, halfway is 1/2 pi. Half pi. And the way we write these when we talk about radians is we don't write the fraction in front. We include the pi as part of the fraction. So this is pi over 2, which is the same thing as 1/2 pi. Okay? If we have half pi and we divide that half in half, like if we divide, say, a 1/2 inch in half, we get 1/4 of an inch, right? So this line here is going to be pi over 4, this 45-degree mark here. Okay? If halfway between 1/2 and 1, if you had a number line, here's 0, here's 1, here's a 1/2. I hope you can tell me what's halfway between 0 and 1. It's 3/4, right? Okay? So we're going to write that 3/4, and we're going to put the pi in the numerator. 3/4 pi. See how we wrote that? Okay? So actually what we're doing is going in fourths. 1/4 pi, 2/4 pi, which reduces to 1/2, 3/4 pi, and 4/4 pi, which is 1 pi, isn't it? 4/4. So my next step here would be what? 5/4 pi, wouldn't it? My next one would be 6/4 pi, but 6/4 reduces to 3/2, doesn't it? And that should make sense, I hope, because when we go from 1 pi, and we're going to continue around the circle counterclockwise, and end up at 2 pi, halfway between 1 pi and 2 pi is 1/2 pi, isn't it? Which is 3/2. So that works. So we're at 5 pi over 4, 6 pi over 4. My next one here would be 7 pi over 4. And then, not surprisingly, when we get back to our positive x-axis, we're at 8 pi over 4, which is 2 pi. 8 pi over 4. Okay? Alrighty, so let's take a look at my thirds now. these other lines that divide each of these quadrants into 3 pieces or into 30-degree angles. Okay, let's take a look at our pie here. How many pieces of that pie do those 30-degree pieces cut into? Six pieces, right? 1, 2, 3, 4, 5, 6. So each one of those 6 pieces is going to be 1/6 of that pie. 1/6 of pi. So this is going to be pi divided by 6, right? My next one would be 2 pi over 6, but I hope you can see that 2 pi over 6 can be reduced, can't it? 2/6 is the same thing as 1/3. So this is pi over 3. Okay? And pi over 6, 2 pi over 6, 3 pi over 6, which is 1/2, isn't it? 3/6, 1/2. This would be 4 pi over 6. That's 2/3, isn't it? So this is 2 pi over 3. All right, and we're still doing 6. 3/6, 4/6. This would be 5/6 of pi. And here we end up at 6 pi over 6, which I hope you know is 1, right? Okay, we've got 7 pi over 6 here. My next one would be 8 pi over 6. 8 pi over 6 also reduces. It reduces to 4 pi over 3. 9 pi over 6. 9 pi over 6. We divide top and bottom by 3. We get 3 pi over 2. So we're here now. Right? Now we're at 10 pi over 6. And if you do the math, you'll see that reduces to 5 pi over 3. And 11 pi over 6. And here is 12 pi over 6, which is 2 pi. Okay? So those are the angle measurements in radians as we go around the unit circle in my positive counterclockwise direction. My positive counterclockwise direction. Again, this is quadrant 1. This would be quadrant 2. This is quadrant 3. And this is quadrant 4. And I don't think we mentioned it before, but those quadrant numbering should make sense now, shouldn't they? If you're going around counterclockwise, you go through quadrant 1 first. Then what's next? Quadrant 2, quadrant 3, quadrant 4. That's why the quadrants are numbered the way they are. Okay? And we did mention also that you can measure angles in a clockwise negative direction. Okay? So if you started at 0 here and went the other way, let's go this way instead. How much of an angle have I moved? Well, I've moved the same amount of an angle as I moved this way, or if I had moved that way, right? That's pi over 6. So what is this? This is negative pi over 6. And I don't want to get ahead of ourselves too much here, but that's a coterminal angle. We're going to do a separate video on coterminal angles with radians. But I hope you can see that you can measure your angles in a negative clockwise direction as well. But the amount of radians doesn't change. It's now negative. Okay? That would be negative pi over 4 and negative pi over 3 and negative pi over 2. The same numbers you see going this way are now going this way. Okay? So that's how we measure angles in radians on the unit circle. Thanks a lot.